All right, so we're going to set up an experiment to measure the saturated hydraulic conductivity of a soil, which just is kind of an opposite of a PERT test, if you know what that is. But what we're going to do is we're going to take the PVC pipe that you have, we're going to fill it up with some soil, and then we're going to move some water through that based on a time frame. So in your book, we're following procedure A on page 70. That's the saturated flow. So in your lab kit, you've got the PVC pipe. You should have something that looks like this. Okay, it looks like some screen mesh that has a plastic backing, so it's actually a sticker, and a rubber band or two. Okay, what you'll need to do is go ahead and separate that out. That's really funny. Okay, I didn't know this, but it turns out that this has a a film over it, which is no good for us because we actually need that screen material. That's what I had hoped was going to be on here. Apparently, it is not. Okay, well, it turns out that the screen material that I enclosed in your lab kit wasn't very good because it actually isn't screen material. It's a sticker with not. I thought this was a screen material, but apparently it's not. If somehow you can get that screen material separated from that stuff, that's good. It kind of happened here when I folded it back and brought it off. But if you can't, that's no problem. Just toss that to the side. You can use a paper towel. Should be just fine to do this, because basically we just want water to soak through and out this, but we don't want the soil to fall out of this. So what I'm going to do is I'm just going to wrap this around like so till it's fairly flat on the bottom. I'm going to go ahead and wrap it in a rubber band around a couple times so it looks like that. Okay? Once you have that, you're going to want to get some soil. Just grab a little bit of soil here. And I'm going to put soil in this till about 2 inches. So I've got my, my tape measure, and I'm going to eyeball it and try to get the soil up to where I have 2 inches of space between the top and where the soil starts. So I'm just going to pour some soil in there. Measure it real quick and see where I'm at. It's getting pretty close. Just a little bit more soil, okay? And it's going to be a rough estimate, okay? And that's fine. We're going to use that 2-inch mark. So I think I've got it to where I want it. Now what needs to happen is anything you can find, a little piece of plastic, something that you can use to hold this up out of this beaker. Okay, so you want to use something that you can set it up on here so that the water will drain out. I'm going to grab a little something that I found. Doesn't really matter what it is, as long as you can set it up so that it'll drain. You might have to kind of rig it however you can. And what you'll want to do, you can use your spray bottle if you want to. It works fine. You can just spray. Let me scoot this screen up so you can see what's going to happen here. Okay, so you can just use a spray bottle and spray in there. That's fine. I'm going to use one of these little canisters to start adding water to the soil. So what I'm going to do is just add water. Okay, and I want to keep that water at what we call a constant head, okay? And that just means that I'm going to try to keep this water as close to the top of this as I can. Okay, so let me show you what I'm doing here. So you see how it's pretty close to the top? I'm going to keep that as close to the top as I can, okay? And your procedures, let's see here. Let me look at what they say. So we're going to be setting up just one column. I'll talk sort of through this and through what it's going to look like according to your procedures manual. So there's just going to be one column. We're only going to measure the saturated hydraulic conductivity of one soil. You can just choose whatever the soil that is. And we're going to keep a constant, what we call a constant head. We're just going to keep it, you can see it's already gone down a little bit. I'm going to add a little bit more. Just as often as it needs it, you're going to add some more to the top of that so that, let me scoot it close, so that it'll remain what we call a constant head, a constant pressure. So we've been talking about water potentials this week and capillary action and all that kind of stuff. And what this is going to do is right now it's just draining down through. I tried to find clearer ones. Sorry, I couldn't find clearer ones. But this is going to drain down through this PVC pipe until it gets to the bottom, and it's going to start soaking out of the bottom. Now you need to know what time you start. Okay, so let's say it's right now. We'll say I'm starting at 2:00 p.m. Okay, you need to keep track of that time. So you would write down the time on your sheet. Okay, your sheet looks like this. The form, you're going to use this table number 8.2. Okay. Soil texture, you might want to texture that soil and see what that is. The time in seconds is how many times between when you started and stopped. So you might write up here, the time was 2 p.m. when I started. Okay. And you can do this for 30 minutes. 30 minutes would probably be a good time period for you to do this. So you're just going to keep adding water onto this. So you're just going to keep adding water onto this for 30 minutes, okay? So your time has to be in seconds. And what you should start to see happening, if you don't see water moving down through your soil and down and out that soil into your glassware in like 10 minutes, then you'll want to do it over a longer period of time. And what you might do is once you start seeing, this might be a better idea, once you start seeing water come down out of that PVC pipe is when you can start measuring. Okay, so once you see water, actually that's what I would recommend. So sorry about the other stuff. You need to wait until water goes all the way through this and you start to see it dripping out of that end. Then that's when you need to start timing this. Okay. So yeah, that's a much better way to go. Sorry to confuse you. Okay. So we're not going to stand here and do this. We'll come back to it later when we've got some water in this. And again, when that starts dripping down there is when I want to start my time recording. And then you should record it from that point on for 30 minutes. Okay, so we'll come back in a little bit. So after 30 minutes, we've collected our water after keeping a constant level on it for 30 minutes. Let's take a look at what we got here. So it looks like we have about 18 milliliters of water. Okay. So that will go, let me focus this real quick. So the time will be, you'll have to calculate the number of seconds that we had in 30 minutes. The water volume will be 18 for this example because milliliters and cubic centimeters are the same. And then you'll calculate the saturated hydraulic conductivity based on what you did here with this. So you'll need to do some measurements about the height that you had this water standing at. So we said that we had soil up to about 2 inches from the top, so that'll be a factor. That'll be the height of the soil. Height of the water is going to be the height of the soil plus that water that we had standing on here, so all the way to the top. And we'll take a look at that equation here in just a second. So on figure 8.3 we have something similar to what we set up. We won't regard this thing right here, but this is what our column looked like. So you can see the depth of soil, the DS, D sub S, depth of soil, then the D sub W, that's the depth of water, and then A is the surface area of the top of the soil right here. So what you'll have to do is use the equation pi r squared. So you'll have to measure the diameter, divide it in half, and then get the surface area of this soil. So you'll have to do pi r squared, and that will allow you to get the surface area of the soil. You have this equation right here where K subs, the KSAT, the saturated hydraulic conductivity, is equal to, here's the volume of water that you collected during the time period. So that's our, for our purposes that was, or for my purposes that was 18, okay? And then you have the depth of soil, which you'll need to measure, the depth of the water, which you'll need to measure, the surface area, which you'll need to calculate, and then T, the collection time period. So you put all that in this equation, equation 8.1, and you should come up with the saturated hydraulic conductivity. You can enter that into the table here. Okay, and once you do that, once you have that saturated hydraulic conductivity, you can look in table 8.1, which gives you the USDA classification. So here you have the rates in inches, centimeters per hour, which is what you've got, which was what you will have. You will have calculated a half hour, so you'll multiply it by 2, and you'll be able to fit it in to what kind of texture this predicts that is that lets water through that rapidly. Again, we calculated this time over here in table 8.2 in terms of seconds based on 30 minutes. Okay, so whatever you get for that water volume in 30 minutes and the time, which will be 30 minutes, you're going to have to pay attention here, because this is in centimeters per hour, okay, and we did it in centimeters per 30 minutes, so you have to double it to make sure you fit into that table.